Welcome to Epperson Prep. My name is Mr. Rallo, and I'll be your instructor for this lesson. Today we'll be talking about integers and their properties, high and low values, and how to use absolute value and the number line. Now, let's go learn the math. So, what would happen if I took the highest mountain and placed it into the deepest part of the ocean? Well, what do I know? I know that Mount Everest is the tallest mountain by elevation on the planet Earth. With a little research, I can find out Mount Everest's elevation. The elevation of Mount Everest is 29,035 feet. What else do I need to know? I need to know how deep the deepest part of the ocean is. I also need to know how to model this with absolute values. Now, let's go learn the math. In order to help us answer the question, what would happen if we took the highest mountain, Mount Everest, and placed it into the deepest part of the ocean, we need to answer a few other questions. How do I show numbers are above or below sea level? In order to do that, I need to know how to use positive and negative numbers. How do I compare different altitudes? We will need to know how to compare and order integers on a number line. How do I compare altitudes that are the same distance from sea level? Remember, one of our distances will be above sea level, and one of them will be below sea level. In order to do that, we will need to construct absolute value expressions to model this situation. Here are some important terms that we will need to know to answer this question. First, opposites. Opposites are a pair of numbers that are the same distance from zero on the number line, but on different sides of zero. For example, -2 and 2 are opposites. Integers. Integers are all the positive and negative whole numbers, meaning no fractions or extended decimals. Absolute value. Absolute value is the distance of a number from zero on the number line. For example, the absolute value of 2 is 2, and the absolute value of -2 is also 2, because they're opposites. They are the same length from zero. Now, let's go work the math. What is the opposite of 4? In order to know the opposite of 4, I need to know 4's distance from 0. So let's start by plotting 0. Now, plot 4 on the number line. Count 4 units to the right of 0. 1, 2, 3, 4, and identify that point as 4. The opposite of 4 is the same distance as 4 from 0, 4 units, but in the opposite direction, left of 0. So count 4 units left of 0. And identify that point, -4. So -4 is the opposite of +4. Now, what is the absolute value of 6 and -6? In order to know that, I need to graph 6 on the number line, and the absolute value will be the distance from 0. And now its absolute value is the length from 0 to 6, or 6 units. Now graph -6. Count 6 units to the left of 0, and label that point as -6. The absolute value of -6 is the length from 0 to -6, which is also 6. So the absolute value of 6 and the absolute value of -6 are the same, because 6 and -6 are opposites. Now, it is your turn to practice the math. Find the opposite of -7, and also find the absolute value of 2 and -12. Pause the lesson and attempt this problem yourself. Here's the answer. The opposite of -7 is +7, and the absolute value of 2 is +2, and the absolute value of -12 is +12. In example 2, we will classify the following numbers using a Venn diagram. Remember that a whole number is a number that does not need to be written as a fraction or as a decimal, and that an integer is a positive or negative whole number. So in this Venn diagram, the orange circle represents all the whole numbers, and the blue ellipse represents all the integers. Notice that whole numbers are included in integers, which means that every whole number is an integer. So let's identify whether each of these numbers is a whole number or an integer. Let's start with -5. -5 is not a whole number because it is negative, which means that it is left of 0 on the number line. So -5 will be placed in the integer section. That's the blue only section of the Venn diagram. The absolute value of 8 is the distance from 0 to 8 on the number line, which is 8. 8 is a whole integer, so it goes in the whole numbers category of the integers section, which means it goes in the orange circle. 9 is a whole number, which means 9 goes in the whole number section. 0 is a whole number because it is not negative. So 0 goes in the orange section. -2 is a negative whole number, which means that it's an integer but not a whole number. -2 goes in the integer section. 3 is a whole number. 3 goes in the orange whole number section. And last, the absolute value of -4 is the distance from 0 to -4 on the number line, which is 4 units, or just 4. 4 is a whole number, so the absolute value of -4 is equal to 4, which is a whole number, so the absolute value of -4 goes in the orange whole number section. Now it's your turn to practice the math. Classify the following numbers on the Venn diagram: 7, -3, the absolute value of 0, 2, and the absolute value of -1. Pause the lesson at this time and try this problem yourself. Now here's the answer. Notice that the absolute value of 0 is still 0 and therefore is a whole number because the distance from 0 to 0 is 0. To find what would happen if we put Mount Everest in the deepest part of the ocean, we need to know how to compare different altitudes. So let's practice with some numbers. Here we will see which is greater, 9 or -12, by graphing them on the number line. First, identify 0 on the number line, and then identify 9 by counting 9 units to the right of 0. Next, identify -12, which will be 12 units to the left of 0. And now, it should be clear that 9 is greater than -12 because it's further to the right on the number line. Now, list the following integers in order. First, starting from 0, graph the number 10, which is 10 units to the right of 0. Now, graph -6, which is 6 units to the left of 0. Graph -13, which is 13 units to the left of 0, or 1 unit to the left of -12. Graph 0, which is already given to us, and graph 2, which is 2 units to the right of 0. Graph 8, which is 8 units to the right of 0, or 1 unit left of 9, because 8 is 1 unit less than 9. Now, to list the integers in order, simply list them from left to right. -13, -6, 0, 2, 8, and 10. If I wanted to know the integers in order from greatest to least, I would count right to left. So 10, 8, 2, 0, -6, and -13. Now it's your turn to practice the math. Which is greater, -2 or -20? And order the numbers from least to greatest: -14, 18, 0, -6, 6, and -18. Pause the lesson and attempt the problems yourself. Here's the solution. You can see from the number line that -2 is greater than -20. Think about it in terms of a bill. If you owe $2 or you owe $20, you'd be better off to only owe $2. If we're going to know what happens when we put Mount Everest in the deepest part of the ocean, we need to be able to compare altitudes. So in this example, who is in the deepest part of the water? To know this, we need to know whose distance from sea level is the greatest. That sounds like an absolute value. An absolute value tells us the distance a number is from 0, and if I take the absolute value of the depths of these people, then that will tell me how far below sea level each item is. First, I'm 56 feet below sea level, because the absolute value of my elevation is 56. The shark is 65 feet below sea level because the absolute value of the shark's elevation is 65. And my teacher is 71 feet below sea level because the altitude of my teacher is negative 71 feet and the absolute value of that altitude is 71. So who is deepest? Whomever is furthest from sea level is deepest, in this case, my teacher. 3 students are exploring a cave. To see who is the furthest from the mouth of the cave, we will need to write each elevation as an absolute value. Now it's your turn to practice the math. Write each elevation as an absolute value to determine who is furthest from the mouth of the cave. Pause the lesson, and when you are finished, hit play to see the answer. Here's the answer. You can see from the absolute values that Kelly is 62 feet from the entrance of the cave because the absolute value of her elevation is 62 feet. Let's go back to the original question. What if we took a mountain and inverted it into the ocean? Well, which mountain should we use? We should probably use Mount Everest, since that's the tallest mountain. Now, what if we flipped Mount Everest upside down? Then the altitude of Mount Everest, which is 29,035 feet, would become negative because the mountain is upside down. So, we need to write the elevations as absolute value expressions. The mountain would be 29,035 feet below sea level, which means that its distance from sea level would be the absolute value of negative 29,035 feet, which is 29,035 feet. We know from the last lesson that the altitude of the Mariana Trench is negative 35,840 feet, which means that the distance from sea level to the bottom of the Mariana Trench is the absolute value of negative 35,840 feet, which is 35,840 feet. That means that Mount Everest's distance from sea level is less than that of the Mariana Trench, so Mount Everest would fit in the ocean if we flipped it upside down. In conclusion, here are the steps to solving a problem involving an absolute value and integers. Identify what you want to know. If you simply want to know the greatest or smallest number, all you have to do is order the numbers on a number line and pick the one that's most right if it's greatest, or most left if it's smallest. If you want to know the distance relative to 0, for example, above or below sea level, then you need the absolute value of your integers. The absolute value is the distance from that integer to 0. The absolute value has to be positive because distances are always expressed as positive numbers. Now it is your turn to go do the math. If the space shuttle's launch time is at t equals 0, express the time at which the solid rocket boosters, SRBs, are ignited as the time before launch. Then find and express the time after launch at which the SRBs are released from the shuttle and parachuted to the ocean. Compare the absolute values of the two numbers. This is Mr. Roloff signing off. Now go do the math.